Yo, what's up, what's up, what's up? Welcome back. Today we're working on my image to text AI. So the idea is that we want to be able to like feed in some picture. We've been using this one as our like example photo. And we want to get out some form of text. Hold on, let's see if we can find one that doesn't suck. Maybe this one. Right, like we want to be able to take an image like this, turn it into text like that, right? And the idea is we implemented like the world's most naive solution, which is like we just take an area of the image and we say, how bright is it? And we look up, where did I put this? Car lookup. We look up, well, we have like some characters and they kind of like increase in brightness, hopefully somewhat monotonically, right? And like we just say, well, how many pixels are in the scene or in our sample, and which character does that map to? So maximum brightness will turn into an @, something slightly less than that will turn into an A, blah, blah, blah. And that's like an okay approach. Let's see, do I have this written anywhere? Maybe we'll look at this here. So this is like what we get if we do that, and that looks like okay, right? But you can imagine that there must be a better solution, right? There must be a solution that picks characters that correctly outline, like match the shape of what's in the scene, essentially. And so what we're trying to do is we're trying to say, like, one, what is that better mechanism, right? How do we determine what is the best character? And two, can we like compute that character efficiently? And so the hope here is that, well, I shouldn't say hope. What I think that we'll find eventually is that it's expensive to compute the best answer. And maybe it's hard to even like find the correct answer at all, right? We might need to, like it might be like kind of unknown to us. And two, that like if we find a good solution, that it will be quite expensive to compute, and you wouldn't want to be doing that in like real time in a video player or something, or just if you're trying to maximize compute in general. It might be faster to train an AI and use that AI to essentially compress down that information into a few floating point operations. Shouldn't say a few, like less floating point operations that it would take for us to manually compute it every time. So the goal is to train an artificial intelligence. Well, calling it artificial intelligence is a little hardcore. It's like more like train a neural network. We'll call it that. To effectively do a better job of this for us. And today's topic is trying to figure out now what like a good metric for the neural network to learn would be, right? Right now we have, this is our target, just the like 5 characters based off brightness, and we want to figure out, well, what's a good labeling function. So plan of action is first like look through what glyphs are available from the font, figure out what they all are, visualize them in some way, and then start trying like different label generation schemes. And this visualization step is probably is going to be like kind of important, because if we like right now when we visualize this, all we see is like the best option. And what I want to kind of be able to do is I want to be able to like look at each individual character that's rendered and say like, well, what are like the other options and why did it pick this one over that one, et cetera, et cetera. So I want something like kind of interactive. Yeah. So I think let's just jump right in. So this is at around 355, and let's like look at all of the possible glyphs that we could look at. So let's look at our lib image to text thing. Hold on, I think I might have this already open. And what we're doing right now is we're using this library FreeType2, I think. FreeType2, is it? Which is like some open source project that basically takes characters and turns them into like images for us. And right now we have like this like, what do? We say, hey, could you load this character, give us like a bitmap representation of that, and then we'll cache that and use it later. And I think what I want here is there's a way to like iterate all characters that are available in the font. So let's see, free type iterate all glyphs. Maybe it was this one? Yeah, here we go. So they ask for the first character in the font, and then they can just iterate them by taking in like the previous one and going next. So presumably there's some sort of equivalent function in like the Python bindings for this guy. So I think we can probably just say like our face has, what was it called? Get first car. Sweet. Okay, so it has that. Nice. Okay. So this guy returns a character code and a index value, which looks like this guy returned the character code and the index value as like an output parameter. And then when they feed into the next character, they use the face, the character code, and the next value. So presumably, okay, here's the get next car right next to it, and you pass in the adjacent value. And so probably it's just something like character and index. Is it a character or character code? What does it return? Glyph index of the first character code. Okay, so let's call this car code and index. And I guess we'll want to render this just to make sure that it's like reasonable, so it doesn't crash. And we'll want to do this in a loop because we're going to look at all codes. Except this stuff is happening outside the loop because it's just the first one's a special case. And then what was the other call? Get next car. So we call on the font face get next car, and we take in our current character code and the index. And this returns a new character code and index probably. Yeah. So we say car code index is equal to this. And this is going to do like caching for us. We might want to like print out what the character code is just to see. And is that it? Is that it? We're going to have to break out of this at some point if the index is invalid or something. What does this return? He says, index is 0 when there are no more codes in the character map. Okay, so we should say while index is not equal to 0. And hopefully that gives us, let's go back into our, we'll go into our visualization script because this seems like where we should start, and we'll just return after we create our image sampler just so we like have something to look at. Okay, so that rendered, or that gave us a bunch of numbers that seem to skip in some cases. Well, let's see, 6, 5, 4. Right, so here we see a big skip from like 8993 to 9115, which means that like at the very least we're getting numbers that are moving not just straight up. So the thought is that like probably there are characters that our font doesn't support, which is, so that's pretty reasonable. And can we like look at the images that come out of each of these guys? Let's for now just render these all into a folder, I guess. And we'll work on like the visualization thing a little bit after. So let's say, what does this guy return again? He returns a cached glyph, which has a bitmap in it. Okay, so we say glyph is equal to this, and we can say image from array. We need to then from pill import image so that we can work with image files. We take the glyph and then we save it as to some folder. We'll call this like output viz output for now because normally we would pass in a path here so we can choose where it goes, but I don't care. This is just really temporary. This is going to go to viz output slash the glyph index. Seems reasonable. And this needs to be, say, we're a PNG file, baby. Okay. So we probably need to make that viz output folder. And then we should be able to run this. And he is immediately crashing on us, so that's interesting. Cache glyph has no interface, array interface, because I forgot to say that there should be a bitmap here. Tile cannot extend outside image. That's odd. So this is in the image saving stuff on character index 0. Okay, let's skip saving for now, and we're just going to print glyph bitmap so that we can get a feel for what's in these guys. So that looks like an N, an L, a backwards question mark. So it looks like these guys are like valid. Can we just look at the one for 0 that's failing? So we'll just return immediately here. Ah, okay. So on the first character, we get an empty bitmap, which is odd. Where is this coming from? We're calling render character, which calls load character from free type, and then extracts the bitmap. So can we look at, and then we turn that into a numpy array down here. So what's like the first thing that comes out look like? Here. Free type bitmap object, okay. And what is that? Because glyph, can I like, how do I like look at the type? This is a free type bitmap. So can we just like go into the free type library and look for bitmap? Class bitmap, here we go. So what does this guy have on him? He has rows, width, pitch, buffer, type list, pointer to the bitmap buffer. Okay, so can we look at like the rows and the width, maybe? Print bitmap, rows, and bitmap width. Okay. So he is 0, 0, and nothing. Okay, so why does that happen? Free type character 0 width. Free type empty glyph. Here we go. They are zeroed after rendering a glyph. He's just saying there's a problem. This is not useful. This is some guy who's lost saying his answer. Fallback for missing glyphs. But like, it shouldn't be missing if the font is claiming that it has it, right? Free type get first car. Is that what it's called? Get first car, which isn't what it's called in like free type nomenclature. This is what it's called in free type nomenclature. FT get first car. And then we can say like empty bitmap. Free type bitmap is empty. This guy's issues OpenGL, which isn't what I want. Load car giving me a garbage glyph bitmap. Here we go. This seems maybe like, turns out there's nothing wrong with my code at all. There's actually bugging one of the dependencies, install wrong side free type. Ugh. Okay. Load car is being called with load render, returning successfully. Maybe I'm not checking for error on load car. Does this guy return if error raise FT exception? So no one's raising exception, so there's no error returned. So why, if this is just succeeding with no issues, maybe the bitmap is not always valid? Free type glyphs. What are these guys supposed to be? So let's look at those like managing glyphs things. So there are glyph metrics, which have like width and height, which we already saw, right? We already saw that we have a width and height, but they're zeroed. I wonder if like they're like, oh, we looked at the bitmap width and height. Can we look at the glyph width and height? Self face glyph width. Like, is that a thing that we can type out? Glyph slot object has no attribute width. So let's kind of look at that. What the hell is this? Glyph slot. So we can call get glyph from the glyph slot. If I remember correctly, they're like, the glyph slot is like the memory for the glyph in the face or something, because the font face is like stateful in some way. So can we just look at the, like, let's look at the glyph. So he has, oh, so he might not be a bitmap initially, because he has a 2-bitmap function, which is interesting. Does he has get cbox, control box? Okay. I thought, does he not have like a width and height on him? This guy's saying that he does. Glyph metrics. Oh, which comes from glyph.metrics. Okay. Which doesn't really seem to exist on here. I don't really see like a metrics thing. But we can try it anyways. So we had the glyph that we need to convert into, or the glyph slot, which we need to convert into a glyph. Fuck, I already forgot. Glyph slot. Get glyph, here we go. Okay, so we'll get the glyph. And on the glyph, there should be metrics. Which is like a private function on the slot, but not on the glyph itself. Where is like get metrics used? Oh, I see. They have a metrics on the slot. Okay. Hold on. So we have our glyph slot, which I don't really fully understand what it is, but that's okay. And let's just say that on the glyph, we have our metrics. And we can look at the width on the metrics, maybe. Okay, here we go. So I didn't actually print where I was saying, so metrics, we'll just print that here so that we can see what it says. And on our initial thing, the metrics for the character we just loaded are saying that the width is 0. So why would that be? What is character code 0? Null character. Oh. Okay. So the fact that this thing is just returning a 0-sized image is like reasonable, actually, given that it's the null character. Okay. So we'll just ignore, for now, we'll say if the length of the bitmap is equal to 0, we can probably just like raise runtime error cannot render, right, for now. And then when we iterate all of our options, we'll just do like a graceful try catch. So on the first character, we don't actually render. Here we try to render. So we say try this, except runtime error. There's probably a few of those. Yeah, that doesn't actually surprise me at all now that I've read that. I guess we'll print failed to render, and we'll print the character code here, which, like this, I think. And then we'll try to save it if we succeed, and we will always try to get the next character, whether or not we fail. Okay, so let's try that. Len bitmap has no length attribute. Fuck. So where bitmap? How did I convert this into an array, actually? Somewhere I say, oh, bitmap buffer. Aha. Bitmap buffer, not the bitmap. Okay, there we go. So we got through a lot of those, and then it failed to render somewhere in generate glyph cache. Oh, that's okay. We'll ignore that for now. Wait. That's weird. So, oh, interesting. So probably like the space, when we actually try to generate our cache with the characters we're using, probably the space already was a 0 width type, and it's probably failing, I bet. We could just double check that. Generate glyph cache. So we're just gonna print trying to cache car, like this. And I'll bet you we're gonna see a space there. Trying to cache space, yeah. And I'll bet you if we take out the space from our lookup table, that stops happening. Yeah, interesting. Interesting. Okay, so we'll have to fix that later. But for now, let's just like at least see something. So we're just gonna throw like a fix me here. And say sometimes this might not be an error. Question mark? Because I don't know what the fuck is going on. And I guess probably we should have a bunch of images that we generated. Look at that! Alright. Okay. So that's pretty sick. There are a lot of characters in here that actually look like they are like interesting in terms of how to say this. Like there's quite a lot of variety in terms of like the space they take up. Now these images are all rendered like for just the character themselves. So you can imagine like if I have like text that I'm like A, B, B, C, right? Like some of these guys are bigger and smaller. So like what we're rendering is actually like the box around each of these characters. And then they have like separate metadata for like where they should be positioned in this picture, which I think we're actually not using right now, which is probably a problem. Well, not a problem yet, but will be a problem. So let's see. Hold on. What's next? So we have these images and we want to see like, we want to put them in the picture that we were using for like comparison, which is like has all of its padding and stuff on it. So somewhere, when we generate our like cache of glyphs in like Torchland, PyTorch TensorLand that we use for like actual training, we take the bitmap and we just put it in the top left corner, I think. So let's see, what are we doing here? Right now we're only iterating over those like 5 characters that we were trying to render before. And now what we probably want to do is we want to iterate over all characters that are available to us. So here we've already rendered them all in our glyph renderer, and they're all cached already. So we should be able to just like enumerate the cache. So we should just be able to say, instead of looking at this like car lookup, we should be looking at self glyph renderer. I don't know what the cache is in here, because we've got like 2 caches here, which is kind of stupid. This one should eventually go away, but for now, glyph renderer glyph cache. One of these is like caching the like padded version. One of them's caching the unpadded version, which we'll eventually have to fix, but no worries for now. So here we iterate all characters in the glyph cache. And let's see if like this fails in any way. Which it does. Hey there, what are you building? We are building a neural network to convert images into ASCII art for us. And right now we're working on our like label generation. So there's some like stuff to read in the top right if you want to catch up, and there's also like an intro at the beginning of stream if you want to go back in the VOD. Okay, so what's he bitching about? He is bitching about the expanded size of tensor 48 must match the existing size 49, non-singleton dimension 0. What the fuck is he talking about? This is in our glyph cache generation. So it's like right here. Right here. Is this open source project? Can I view the code base? Actually, yeah. Here. I'll post a link to it in chat. It is here. There's not much going on yet. We're pretty early in the project, so it doesn't really do anything of value. But eventually, as we get further along, it'll get more interesting, hopefully. Right now, it's like the dumbest neural network of all time. We're actually just doing like, we take our like inputs and we map them like directly to the outputs, every single one. And we're just like, please figure it out for us. But that's because we're just doing like we were just getting like, doing our like hello world essentially. And we're hoping that after we create a better metric for success, we can then train a more complex neural network. But first, we need to decide what we want to do, and then we can evaluate the like performance of different network architectures and stuff. But we can't do that until we know what we're trying to do. Okay, so I don't really understand. Before this code worked, where we said like I'm going to render a character of these like specific height and width, and then we're going to inject that into the tensor, and that worked for like a subset of characters, I guess, but maybe not for all of them. I don't really understand why it's different now than it was before. So let's take a look here. What's it saying? 48 is not 49. Oh, shit. So before we were assuming that every character had the same width because it was a monospaced font. So what we did was we like pre-checked the width of all characters by saying like, hey, how much do you want to move every time you type this? But I guess probably what was rendered here is like a different size than that. Oh, but that should be fine because we were only trying to inject into our like cache here up to the shape of the tensor. So can we like maybe print item shape? Bitmap.shape, and I'd like let's just try to get a clue here for what the fuck is going on. So all of these worked. Aha! Okay, so what actually happened is this one's bigger, which is interesting. Okay, so for now, let's just say fix me. If character is too big, we need to handle that more gracefully. But for now, we're going to say that the width is the maximum of the item bitmap shape 0 and or sorry, the minimum. We want the smaller of the bitmap shape or the item, like the cache width. Item tensor shape, I think was 1, I think. And this is actually height because it's height row major. And then width, we just increase both these indexes by 1. Oops. So 1 and 2. I don't know why this like fucking autocomplete shit is. Oh my god, go away. I'm gonna lose my mind. I'm gonna lose it. Okay. And so then here we go to height and width here. And hopefully that will now not crash at least. Fuck. Print height width. $48.26. Okay. Oh, here we need to also truncate this guy. Like this. Okay, that should work. Okay, there we go. So now at least they're all generated. And then let's do the same thing where for now we just render this out to a folder just so we can see what they look like. And then we'll start working on like actual visualizations. Okay, so we're going to say for I in our cache, the first dimension of it, because this guy is like he's like num items by width or by height by width. So we iterate over num items and then we can say item tensor I. This should give us height width. So an image essentially. And we can turn this into a NumPy thing so that the image parsing library can use it. So we can say image from array. These are normalized, so we actually have to multiply them by 255 to get them back into floating point to like the space that PIL likes. And then I think we say to torch human date or something, or NumPy Uindate. Okay. And then we save this to viz output padded format car. And we save this as a PNG, which I think will work for us. We'll see. Let's run it. So he's actually going to complain that, oh, first of all, we can't iterate integers, right? So this is range. And car isn't available here, so we should actually say that this is, oh, we'll just use I, the index of the tensor for now. ND array has no attribute 2. I thought there was like a way to cast. How do I cast numpy arrays? As type. As type. That's what I want. Alright. Alright. So now they're complaining that that folder doesn't exist, so we'll make dir viz output padded. Just quickly look. Alright. He didn't like that 255 multiplication, probably, but we see something that's like somewhat, can I like just say I want 400%? Oh, it's resetting to fit every time. That's annoying. Oh, that's so annoying. Okay. Anyways, there's something like slightly wrong there. It's like edge masking them for some reason. But we can see like there's like a problem where every character is ending up in like the top corner. Can we go back to browse view here? There we go. But other than that top corner thing and the outline thing, it seems to be like okay. So let's just fix the outlining. Can we maybe... What happens if we don't do that 255 conversion? I'm pretty sure that that's an issue, but I just want to double check. Yeah, cannot write mode F as ping. So I think here we just say, can we like... Can we convert and then say mode is equal to L, I think was the mode for 8-bit black and white. Here we go. It's reloading all the pictures after our fancy. There we go. That looks better. They're all filled in now. Okay. So probably last thing to do here is, whoa, what the fuck? Why is this one different? What's going on here? 48 by 29. Oopsies. How do I go back to where I was? 48 by 29. I don't understand how one could possibly be a different size than all the others, because these are coming from a array that is like fixed at a certain width height. Is this broken? Discard changes reload. Oh, I accidentally rotated it. That's why. I see. But he's still 29 by 48, and the rest of these guys are also 29 by 48. So this is just a broken visualization. Okay. In fact, they all break after I like go in and out. That's so fuck. Oh, what a... Okay, that's fine. Okay, so we do know that we have like a good selection of characters, and the mechanism of like caching them the way we were before is probably still going to work. We just have to make sure that we're getting like their offsets into the array correct. So I think we're not like looking at that at all right now. So I think, if I remember correctly, when we did this before, there was like offset fields that come out of the glyph. So here, bearing, was that, this is a horizontal distance from the current cursor position to the leftmost border of the glyph. Yeah. So, oh, for horizontal. So we want horizontal bearing X and Y, probably. Distance from the current position to the leftmost border. This is the vertical distance from the current cursor position on the baseline to the topmost border of the glyph's image bounding box. Okay. So, I guess we'll have to take the bearing X and bearing Y and figure it from there. Be sure not to confuse this with the FT size metrics. We'll figure that out later. Okay. So let's just see, let's like just look at what these hor E bearing X. Can we just like print this and look at what they are for like X and Y before we get crazy, just to make sure that like we understand the data type, which he doesn't own. He doesn't have one of those. Was it because we needed like metrics? Maybe. Okay, and we should actually print out hori bearing X and hori bearing Y. Okay. And can we just where was this other print coming from? In our like other glyph caching? Ugh. Lib image sampler. Here we go. Prints in here. Let's just nuke these guys. We don't need them anymore. Okay. So X, some of these are negative, which is a little concerning. They're really big numbers, but that's okay. I guess for now, anything that has negatives in it, I'm just gonna clip. Right, so what this is kind of saying to us is if our cursor is like, we have like text, and our cursor position is like on the baseline, it said. So we're gonna like write an A, right, and it's gonna be like move the cursor over, and then we're gonna write a B, and we're gonna move the cursor over, and it's saying that like if you were to draw a box here, boom, 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 some characters will be like outside of this box, and I think I'm just gonna say like, fuck it, ignore that. I think that like I'm just gonna like delete anything outside the box for now and just see what that looks like. Assuming that like that seems to be like a rare case, right? All of these guys seem to be positive for the most part. I don't see any other, like, yeah, I see very, very rare negatives, so I'll just clip them. And or maybe we like our current mechanism of like comparison of like looking at what's in the box. If we clip stuff, we're gonna like end up with stuff outside the box that the neural network isn't aware of, and so it might like try to use characters with that. But maybe that's okay if the values are like small, right? If we look at, can we try to find a negative value in here? Right, negative 64. These are in units of 64ths of pixels, so that's 1 pixel out. And so like maybe that doesn't fucking matter. Maybe it does. Maybe it doesn't. I don't know. We'll see. But yeah, for now we'll just clip. Okay, so we need to store these bearings. So we're going to store X bearing as a float and Y bearing as a float. And then here, we're going to store those as X bearing is equal to this thing. And Y bearing is this bit with Y. And when we put those into the like padded box, we're going to say start is equal to I guess we're going to divide these by 64 as well. Okay. So start is the item dot X bearing. We'll call this start X. And we're going to take the maximum of the bearing and 0, right? If it's below 0, a negative value, fuck it. Which actually means that if the bearing is negative, we actually have to account for that in its width. So here, we're actually going to say if item X bearing is less than 0. Dude, this fucking, I'm going to lose my mind with this like auto completion thing. I don't know what it's doing, but it's fucking pissing me off. Okay, so if it's less than 0, we're going to subtract that much from the width. Sure. Sure, that makes sense. And we're going to have to make sure that width is still an integer here. And we're going to have to do the same for y. So here, this is height everywhere. And this is y. And here, the start x is the maximum of the x bearing in 0 as an integer. And the start y is the same. Yeah, okay, that seems reasonable. And then here, when we plug it in, we just start at start x to start y to start y plus height, and start x to start x plus width. Sure. And here, instead of coming from 0, if the y bearing is less than 0, we're actually going to have to adjust that. So fuck. So maybe height and width stay the same. Fuck. Okay, so we have, what are we doing? We have some character in a box. Beep, boop, beep, boop. Let's draw a box here. He's like, the letter A or something, who is perfectly aligned in this box. Then we're trying to take that and put him in the standard box size. And we're kind of saying oh, he might have clipped out over here. So his start value, or he might have this might be position 0 over here. Which means that we have some other, we're trying to copy paste them in like this. Which means that we need to offset this to here. Which means that these can't start with 0. So here we have height and width are these guys. And maybe we keep height and width as is. So we'll call this we'll source height and source width. So that we're clarifying whether we're talking about source or dest here. Then we can say that the adjusted source width is going to be source width, but if the bearing is negative, we're going to have to subtract that. So adjusted source width is minus equal to bearing. But maybe we don't want to store the width that way. Maybe we want to store it as start and end. Sure. Yeah. So source, we'll say source start is equal to 0. Source end is equal to 0. Start x. And source start y. Sorry, we're doing this for x and y. And height and width can stay. What am I trying to say here? Yeah, sure. These can just stay like this. We subtract the width here, and we also increase the source start x by this. Yeah. And then here we also have to make sure that these guys stay as integers. So source start y is this. And source start, oopsies. Source start x still needs to be an integer here as well. And then here we can, instead of plugging in 0, source start x and source start y. That might make sense. Maybe. Here he doesn't like the expanded size of the tensor must match the existing size of non-single dimension 0. So we fucked up somewhere. So let's print out source start x. Oh. This is y, and this is x. Whoopsies. Swapped height and width, the classic. He still doesn't like that, so start y height, start x height. And these should be dest start x and dest start y, just to avoid confusion. Okay, so here the height. Here we need to add source start y and source start x, the width and height. Yeah. Because here we've said, like, this is like, it's like initial width. We like decrease it. But then instead of starting from 0, we start at like s. So yeah. Okay. That makes sense to me. Probably not to those listening, because I didn't explain it very well. Also, it doesn't work. So clearly I'm fucking wrong. So let's print out some of the stuff we care about here. So we're going to say, what are the values we care about? We have source start x, source start y, width, height, and dest start x and dest start y. Okay, so these are all the values we care about. And then we just do our little Vim macro magic, I guess, to say yank in word, put in a quote, paste it, and then go to the next line. There we go. And that should tell me, so we have 0, 0, width 9, height 37. And we start at 10, 35. So we actually should write down the bearings as well. Oh, which we do. Oh, maybe we don't. Let's write down the bearings as well. Bearing x, which is the glyph, our item bearing, or x bearing. Like this. Yeah. And we do the same for y. Y. What are we missing? We're missing something. Okay, so we start at 10, 35, 0, 0. Okay, so that makes sense. So our width. Oh, where does it? We should probably write down the like initial width and height as well. So here we have item bitmap shape 0 and 1, and we could say bitmap width and bitmap width again, because the first one's height. Perhaps I forgot a comma. I definitely did, but fuck you for making me sound stupid. 10, 35, 37. Okay, so we have a width and height of 9 and 37 that is supposed to be offset by 10. So our initial point in our destination should be 10. Yep. And the final location should be 10 plus 9, so 19. And so the width is 9, which means that here we should have x plus 2, so we should have 10 to, yeah, that's the right size. So he's saying that the expanded size of tensor 13 must match the existing size 37. Okay, let's look at the other one. So our height is 37. Okay, which lines up. And the bearing y, so he starts at 35. Okay. And he goes for 37 more? Does that even fit? Am I high? So we're trying to map something that's 13 by 9 from 37.9. So something's fucked up. Something's fucked up. The 13 is wrong, because the height of this guy is supposed to be 37. So we have dest start y 35. Okay. Because bearing is 35. Is the bearing y to the top left or the bottom left? The vertical distance from the current cursor position on the baseline to the topmost border of the image bounding box. Oh, fuck. Okay, so the bearing y is like inverted, right? Because we have, where is my color paint? So here we're drawing on the baseline. We have an image that we're trying to put in like here. And here's saying like, what is this distance? Where are we starting? This is bearing y. And our top left is like up here at the top of the box. So we actually have to do like the height of our thing minus the bearing y. Yeah. So the source start y is equal to the height. So what is our item tensor shape 1 minus this? And is this used anywhere else? Y bearing? No. Okay, does that start working? Fuck! So our target size are still 13 rows, which still feels wrong. So here our source start Y, great, 0. That makes sense. So then we go from, oh fuck, we want dest start Y. Oh shit, we're using here. Fuck. Oh god. That subtraction should have been here, I guess. As may not want the baseline to be right at the bottom of the image. That seems likely, but when I was scrolling, I didn't see any negative Y bearings, and I think that we can also like clip stuff in that case. So I think it's not the best, but I kind of want to just get like something, and then we can see how it looks after. I agree though. I was thinking that like, because like there are things that might fall off the bottom, right? Like if you have like a Y, like is this tail underneath? I don't know. We'll see in a sec, I guess. So sorry, we wanted source dot shape 1 minus this. Yeah, makes sense. We'll say 35 bearing with 37 height is drawing 200 the baseline. Yeah, we'll have to live with it for a second. Not source. Am I fucking high? Where am I putting this into? Item tensor. I just started using Vim, and I think I might need to amputate my right hand because of the mouse. I would argue if you're complaining about swapping back to the mouse over and over again, I think people who say don't use the mouse are wrong. I think the mouse is fine, and you will eventually learn to do things that are faster. Oh no, the HDKL is gonna kill me. Oh, are you getting like a little bit of like RSI already? Like a little bit of ouchie? Expanded size 35 must match existing size 37. So probably now we're going off the edge. Probably. Which means that we need to adjust the height accordingly. So height. I see. So we have to like our Y calculations are all wrong here, because we're only caring if it's less than 0. But really, we should be caring about if the bottom is going to go under the maximum or something. Ugh, what a pain in my ass. So we just need to clip. We'll just say dest end Y is equal to dest start Y plus height. And cap this. We'll say this is the minimum of this or this and the item tensor dot shape 1. And I'm just gonna throw a big fix me on here and be like, obviously we need more constraints here. But I'm just trying to like get past the parts where it's scratching. I just want to like see something so that I can get a feel for how fucking wrong what we're doing is. Expanded size is tensor 35.9, and the input is 37.9. So we also need like source end Y is equal to the minimum of source start Y plus. I guess we want the source end Y is going to be the source start Y plus dest end Y minus dest start Y. Jesus. That does not look right at all, but again, we're just trying to get something that we can refine later. Okay, we're close. 37. Now we have to do the same thing for X. So source and X is the start X plus the distance on the other guy, which means that dest end X is going to be the start end X plus the width. Jesus. And which will probably almost certainly come back to bite me in a second. But again, Try not to think about it. I have escape mapped to JK. Highly recommend. Some people do JJ. I did that for a bit, except that it kind of like fucks you up when you're like spamming up and down. Like if you're like trying to like navigate quickly, you go like down, 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 up. Like sometimes that like fucks shit up, which is kind of annoying. I think like escape. Oh yeah, I use escape itself, and it's not too bad. I don't know. It doesn't feel like I don't really notice it. Start and X. What the fuck am I talking about? Source. Dest start X plus width. There we go. Okay, please just. Oh my god, just get me there. So the output is still 29, probably because I didn't use source index down here. I did. Did I not use dest and X over here? I did. So how are these like not matching up? If I have start to end my because maybe the 27 on input, 29 or 29 on input, 27 on output. Why is this not matching up? Print. I guess we can actually just look at what it prints. We have width 29, dest start X 2 to 11, and we should print the source start and end as well. Start and like this. So we have this is going 0 to 29, and I'm not logging dest end X either. So here we say start end and log those. So we're going 2 to 31 and 0 to 29. So are those not the same width? I guess our source end of 29 is out of the range or something. Oh no, this is source dest. 2 to 31. What is like the width of our entire tensor? Item width. Item tensor width is the shape of the tensor. Item tensor shape with the second index, I think. Right, so this thing's only 29 long. Okay, so we're using the full 29 width. That seems fine. Dude, I swear I'm like losing my mind. But we're trying to move from dest X to dest N31. So the end is out of range. So we have to clip it. Which we said, obviously we need more constraints here. So one of these is that we have to do the same thing for the width. Where we clip it. If it is not good. Hey, could you please get that fucking... Oh my god, get out of my face. Go away. Why? Go away. Why do you think you're in something? Okay, there we go. Much better. Okay, so we're on a different one now. 929.96. So what's happening here? Bearing of X is negative 23, so that's almost certainly a bug that we're not handling correctly. Or like a constraint we're not handling correctly. So source start, negative 23. Which means that our source start has to be clamped. Source start X is equal to the maximum of the source start X and 0. Fix me. Not thought through. Dude, okay, I'm going to lose my mind. I'm going to quit this, quit everything, and restart it because something is like in my editor is just trying to like piss me off. It's trying as hard as it can to make me lose my mind. Okay, so this time now we have bearing X negative 1.0. And here we're trying to set 35.29, 35.28. So clearly we have a width of 29. We're trying to put out 29. And our source start X and Y is 0 to 29. And our dest is 0 to 29. So why is either of these failing? They're the same. We have a width of 29, 0 to 29, bitmap width 28. So we've actually ended up going higher than the bitmap width. Oh! So we have to clamp this as well to... we have to clamp the end of this guy... to also take into account the width of the input bitmap. How have I not already done that? The width is here. Our dest end is the width minus the start. This guy's somehow ending up too large. Maybe we should actually like try to do a proper like clearly we're starting to like have too many constraints, and maybe we should just think about the generic case and write like a proper function to do it. Right? All we're trying to do is we're trying to take a thing and another thing and find the intersection and copy it in. Right? Oh, but it's not that simple because there's also like offsetting as well. Fuck. So maybe we are just slowly arriving at the right answer. I think what I'm going to do for now is I just really want to see something. So let's just kind of... but we have like... Yeah, fuck it. Except... we'll print failure. And we will come back to this, but I just want to see literally anything at all, so... Viz output padded. So let's see if these guys look a little more reasonable. So we have things that are kind of fixed at the bottom. We have things that are definitely getting clipped. But those look like ligatures, right? Like here, those are like arrows that are probably actually a little bit too long intentionally. The height stuff is concerning me. It feels like everything is centered incorrectly, maybe? Can we like get back to this view? Like, can we go back to like letters? Let's just get into where it's comfortable, which is letters. And probably what's happened is that our baseline, like Smutty Monkeys was saying, we have our baseline at the very bottom of the image, which means that anything that like drifts off the bottom is just getting clipped. Big mistake there. Right, so like let's find like a lowercase letter that has a tail. Surely there's one in here. Surely. Do not have lowercase letters? Am I high? Where's like my lowercase y and stuff? Oh, here. Yeah, see like this y is just getting like completely cut off. How are we supposed to know, man? How are we supposed to know what like the maximum... I guess like we could like check all of the bearings. Find the worst one. Oh, okay. Here's what we're gonna do. We take a function. We make a function that computes the border of the image in cursor space. Relative to the cursor, what is like the range of characters? Then we can like figure out from that what like the maximum offsets are going to be. And then we can set the baseline according to that. I think. But what if all of our characters don't fit in the box? Then we might have a problem. What if we just set a baseline that's not 0 and we just pick one? Right? We can kind of like eyeball how fucked up it is right now and just guess, right? So these are 48 pixels tall, and we probably want to go like, you know, a fifth of the way up. So let's just go up maybe like 8 pixels. Just for now. So source start y We just make 8. Is that right? No. We want the destination y to be changed. Can you get the descent from the metrics? Maybe. What is an FT glyph metrics? If that just gives it to us for free. Did I just go to the same fucking thing? No, I didn't. Okay. Glyph metrics. Metrics. Size? No, this is SVG glyph mag. Managing glyphs. This is where we just were, and it's annoying that these hyperlinks don't work. But we could maybe look at them in Python. So somewhere we probably look at free type, and we can look at what's in glyph metrics. Oh, but these are the metrics for an individual glyph. Is there like a font face metrics? Like, or like average? Oh, what's this? Global glyph metrics. Here we go. Can you get the descender? So the descender is the vertical distance from the horizontal baseline to the lowest character coordinate in a font face. And there's like a maximum advance width. Interesting. But for us, we kind of want like the average advance width, not the maximum. And we can just, maybe we just remove any characters where the width is larger than our expected width, because like those aren't really monospace. I'll have to think about that. But descender, okay, yeah, vertical distance from the horizontal baseline to the lowest character coordinate in a font face. Unfortunately, they don't define the descender in a uniform way. For some formats, it represents the set of all capital Latin characters. Jesus Christ. Okay, I'm going to ignore, as with all font things, that's complex. And I think we can just subtract 8. Here. So the shape minus the bearing minus 8. And let's just hope to God that looks more reasonable. Okay. Maybe 8's a little high. These hats are getting kind of clipped right on the top. So maybe we'll subtract like 6. And we're just going to say, fix me. 6, hard-coded, obviously wrong. Right? But for now, I just want to, again, get somewhere. Okay, so let's... Can we look at like letters and see if like A, B, C, D, E, F, G. G's a little... These are going off the edge, so we're going to go back up to 8. And let the hats kind of be on the wrong side. Come on, give it to me. A, B, C, D, E, F, G, H, I. Yeah, okay. That's good enough for now. Obviously, this is wrong, and obviously we're going to need to come back and fix this. But I'm letting this distract me a little bit from what I actually wanted to work on today. So let's say that we will... hard-coded baseline offset is obviously wrong. I do just want to get into like the next stage of this. So what I wanted to do, fonts are such a rabbit hole. Yeah, I know. I'm like certain that even like this scheme of like stamping in fonts from our tensor like this is like wrong, right? We're like pre-generating a box, rendering the guy in there, and then saying like, okay, later, now I'm gonna like just put this in the box where it goes. But like that's clearly wrong. Even for a monospace font, it's clearly wrong. So, yeah, we just have to think about that. I'm curious about like, we were seeing like programming ligatures with like, not like, we were seeing some of these guys. Where are we looking? They were kind of like drifting off in like the X direction, and I thought that was kind of odd. Maybe not anymore. Maybe they're all fitting now. Okay. There are a lot of empty ones, which is going to be a problem for us. But we can just, if these guys are all rendered as nothing, that's okay for now, right? What'll happen is if we try to like use them, they will just be used as if they're a space character, and I'm okay with that temporarily. And so we'll just have like multiple space characters, and we'll have to like make sure that we're careful about our like neural network. Yeah, most of them look fine. Yeah, I think I'm decent okay with this for now. Okay. We're gonna cross out this all and write some glyphs, and then we can say that we did it. An hour later. Okay. So the next thing that I wanted to do was I wanted to be able to look at the scores, not just for the label that was like the winner, but I want to look at scores for all labels that we could possibly look at, right? So I want to be able to like look at the picture. Hold on, let's see. So we have our like sample image. Not this one, this one. And I want to be able to like look at like, you know, right here. And I want to be able to say like, okay, which one was like picked here? And what are like the runners up? And like, should I adjust my metric in some way to make it so that the runner up wins? Because like in some cases I might like the look of like other ones better. And so what I'm thinking, hand wavy. I'm thinking we have like some application, boop, 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 and we have like our picture. You know, here's like our little like mountain range, and here's like our little like landscape and like the sun. And I want to be able to like, I want to be able to see like the text representation. A, B, C, D, at sign, whatever, right? I want to see like what it converted to. And I also want to be able to like click on this, then like get a box drawn up here and have like all of the characters down here sorted by like which one was best, right? So we might get like, you know, this guy, and he's gonna have like an at sign, and then like some like text here that's like, oh, this is my score. And then like the next one, he's gonna be like, I don't know, he's gonna be like A, and he's gonna also say like, here's my score. And maybe like, I don't know, there might be like other metadata we want to look. And then as I like click on here and I move this red box around, maybe we should also show, we should show that specific section probably as like what it looks like. So we should see like a blown up version that's like, you know, we're going to show the image and he's going to say like, oh, I'm this part of the mountain here. Right? That's what I'm thinking. And so I'm also thinking, I want to whip this up as like a web UI probably for our training process, for a few reasons. One, it's like zero dependency from Python side, right? You can kind of imagine like, yes, the browser is like a fucking massive dependency, but everybody has a browser installed already, so using it as like a free dependency there is like kind of sick. I kind of want to be like more comfortable with whipping up quick visualizations, and the browser is like an easy, you can do that in any language that has a TCP server, right? That's pretty straightforward. And three, like, I just think that like web dev, like there's a lot of in the world of web dev right now, and I'm like, my web dev's like shit. So using this as an excuse to practice that a little bit. I want those muscles to be strong and practiced. So I'm thinking, yeah, we'll go to like browser website, localhost, and we'll see this. That's what I'm thinking. That's what I'm thinking. So let's go into our visualize, and we can, what's the like Python HTTP server? How do we like run a server? So they say that you have like HTTP server, you run it, and you have like a handler class. And if I remember correctly, they instantiate an instance of the handler class for every request, and your handler class is the one who actually does the like response handling, and the server is kind of like pretty dumb, if I remember correctly. So let's just, so there's like from HTTP import HTTP, or http.server import HTTP server. Nice. And I guess we'll just do like a simple hello world of HTTP servers. So here we'll say what our server is a new HTTP server, and then server serve forever, I think was the thing here. And so we're missing a server address and request handler class. So I think that this is like, you say like localhost, and I want to serve on like 9999, and request handler class is my request handler, if I remember correctly. So I think you're supposed to subclass this guy. Here. This class is used to handle all HTTP requests that arrive by the server. By itself, it cannot respond to any actual HTTP requests. Blah, blah, blah. Whereas, like, can we, like, when you run, like, HTTP server, it runs like a server. Yeah, it has, like, an if name equals main. And what do? They create, like, simple HTTP request handler. That sounds right. And then they create, like, an HTTP server with the handler class of simple HTTP request handler. Nice. So we can like look at this guy's for example. So he implements like do get, do head. Okay. So I think if I remember correctly, last time I did this, you implement do get on this guy. So this guy theoretically calls do get. Maybe it's like a little more complicated than that. Yeah, here. mname equals do underscore self command. Oh, dude, I hate this shit. This makes me hate Python so fucking much when people do this stuff. I understand that it's like convenient in terms of like writing it, where you're like, oh, they might come in with a get request or a post request. And so I just want to like stitch those together and call the function called do underscore string. But it's like, dude, converting strings into functions and calling them is just, how are you supposed to figure that? Like, I would prefer if I could grep in like some reasonable way. That's crazy. Okay, sorry. So all that to say, probably if I am subclass from base HTTP request handler, if I'm base HTTP request handler, and I say def do get takes in self, let's just print something here and see what happens. So we run our server after we generate all our images, and if I go to localhost 909, we do see that we did try to run that function. And so we can look at, then we go back and look at the example, and simple HTTP request handler, which if I remember correctly, this guy just serves like files. So he sends a like header, okay, who probably writes to like some state in this guy. Send response, end headers, send header. Okay. Let's just try, what does he do for like the actual content of the file? Let's start there and we can figure it out from there. So he copies the file that he gets into W file. So I like say like self W file write hello. Do I like get something? If I go to that site, bytes like object is required, not stir. So probably have to like encode to turn from a UTF-8 string into like a byte array. Okay, so we've got something back, and his response was just the content. So presumably I have to like, if I want to say that this is like something else, like an HTML file, I probably have to like send the headers myself. So probably these guys, when he says send head, he sets the content type, content length, and then ends the headers. Okay. And he sends the response as well. Okay. So let's just kind of yoink this shit. I don't really care about anything, I think, except for content type. Here we need HTTP status, this, and here we're gonna say text HTML, I think is what we want to do if we want to do HTML. And let's open up like resource index HTML and just send that. So f.read, I think, maybe .encode. What do you mean bracket not closed? What the fuck are you talking about? How is that not closed? Are you high, indexer? Do I have to specify? What do you mean not closed? Dude, I'm gonna lose my mind. I'm gonna lose it. And now this like fucking pop-up is back. Holy fuck. Okay. Looks like maybe it's okay. So let's now make touch res index HTML and serve. Also, let's get rid of all this other stuff that's not the server that's running before that, just to speed up our startup. Okay, so we got back nothing. We did get back that it's an HTML thing, as well as a date and a server, which I didn't set, but that's okay. And so now let's like, hello world HTML. Let's just yoink this. Whoop. And paste it in here and see if oh, there we go. Okay, sweet. Okay, so we've got like kind of like the basics down. This is gonna happen probably no matter what I type in here. Yeah. So we probably also have to like look at the path, which if I remember correctly, comes from like, that's just like a member I have on here. Yeah, path, here we go. So I should just be able to like look at the path and like switch behavior based off of that. And let's see, what do we want to do first? The first thing that we probably want to do is just show all of the images of all the glyphs again. Because we know that we're going to want that and we have those available to us. So how do I have state in this guy? This guy gets instantiated for every single request, which means that he has to like, contains a server instance. So I guess I could probably like shove the state in the server, which comes from an HTTP server. I can say here, I'm gonna take in self, the glyph, the sampler, image sampler, and then everything else. And I'm gonna call super. I'm gonna initialize him with args and keyword args. What's my distro? I'm using NixOS, but I always say this with a guard of, I would not suggest NixOS to anybody who's just being like, what distro are you running? It's one of those ones where if you find it yourself and you're looking for what it does specifically, it's like pretty cool, but I definitely wouldn't like, if you're like trying to just pick a Linux distro, it's not the one. Yeah, okay, I know the distro, bro. Okay, just double checking. It's like the same thing as when people ask what editor I'm using. I'm like, I'm using Vim, but I wouldn't tell you to use Vim unless you like really wanted to, right? It's just, I don't want people to like copy what I'm doing and be like, what the fuck is wrong with this guy? You know? Okay, let's store the image sampler. NixOS similar to Terraform? Yeah, exactly. I used Terraform one time for something, and I was like, damn, I wish my operating system was like this. And then I Googled, I was like, oh, it can be. That's sick. It's so cool being able to have like your whole operating system like tracked by Git and a config. It's just so sick. Okay, so let's see. When we're getting something, let's say that we want to like, we want to be able to get each glyph. So we need to be able to check what the glyphs available to us are. So we can probably say in our image sampler or server image sampler. He doesn't like that for some reason. maybe he doesn't know what the type of server is because it's just the base class. So we can just say assert self.server is an instance, I think, of my server, which means that now he knows that the image sampler is there and he can stop being pissed off. But he still doesn't know what methods are available on him. So here, I guess we can say that the image sampler is always going to be a image sampler, and hopefully that helps like the type resolution here. Yeah. So here we have the cached glyphs, and I guess we'll just say how many of them are there. So we'll say return, or we'll say that the shape of this guy, the first element, the first index of the shape is going to be how many elements there are, and we can return that if somebody says if self path is equal to glyphs, we do this stuff where we say it's okay. Instead of HTML, it's going to be JSON, I guess. And then we write out this encoded as JSON. So I think that there you can just say import JSON, then JSON dump string of this, and then we just say write output encode, I think. And then if I go to the path of glyphs, I should see. So if I go to glyphs, he's mad. What doesn't he like? So I am not an instance of my server. So that would do it. So here I just want to write my server. And then I also have to pass in the image sampler, which means that I have to do all this stuff first again. Okay, refresh. Hey, okay. So here I got, instead of what I actually wanted, which was like a list of possible answers, I just got how many there are, which I guess is reasonable. This can tell me how many elements there are. So yeah, that seems reasonable. Okay, so we can say here that I want like num glyphs is this many glyphs. Do I have to put this in a string? Probably. Refresh. Okay, here we go. So now I have like, I can say like, hey, here are my glyphs. How many glyphs are there? That's not really like the rest way of doing things. Usually people's like you ask, like if I wanted to say like I want which glyphs are available, and then I want to say glyphs 0. Like usually I think you list all of the possible options here. But fuck it, I don't care. I'm not designing this API for anybody but me, so I don't really give a shit. Okay, so now we have like a way to get how many options there are, and let's say that I want to like get an individual glyph. So we want to go like glyphs, else if the path starts with glyphs. Okay, yeah, that sounds right. We can extract the path after however many characters this is, which is 7. And we can just look at that thing. So we can say self server image sampler glyph cache. The glyph num cast to an int because it's probably is a string here, but this will parse it for us. And we say image is this. Then we need to convert the image to numpy so that we can like use it as an array. And load that into like an image that we can serve somehow. So we want like image from array image. Image as a numpy array so that we can use it. And then what? What do we do with this? Save it somewhere? Like can we convert the image into like a PNG in memory? PIL image save in memory. I don't know. Oh, that's funny. So you like create a file in memory and then save to that file as if it's a file, and then you can like serve it directly. Okay, that makes sense. So can I just save to image save self w file? Format is equal to PNG. Like, is that legal? So if I go to like glyphs, like 45, I'm trying to convert /45 to an int, so I just had my index off by 1. This should be 8. And then I go here again, refresh. He doesn't like, cannot write at mode F is ping, right? So I have to convert this guy to mode L for 8-bit no color. Okay, we have a PNG. Okay, we're close. So we just need to set the headers here. Yeah. Was this was image PNG or something? We'll see if that's right. I'm not positive, but hey, there we go. Okay. So we have our picture. And now in our index HTML, we can make a little script like this, and he can say, what's he gonna do? He's going to actually, can we make it like an actual, can we just make it like an actual index.js, just because I want like some form of like syntax highlighting or something, just so I can like make sure I'm typing things right. So we can say that I want index.js, which means that here we actually have to check the path. So we say what? We're serving from resource. So we just append path to resource. We'll say file path is equal to this, and then we just say with open file path as f. Obviously, this is like quick and dirty hack, but we're just dealing with it. Oh my fucking god. I'm gonna lose my mind with this like fucking pop-up. Holy shit. Okay, does that at least like run? So we run this, and he says res fav icon is not available. Res is a directory because we need like res index HTML. Okay, so the index loads, and we load index.js as a script. MIME type is wrong, but it's loading that fine. Okay, so we should be able to say now, if we go into our index.js, we should be able to say, what? We say like, console log hello world. And we should see that that runs when we refresh here. Sick. Okay. So we've kind of stitched all that together, and now we want to say what? In our index, we're going to run like some initialization function, and he's going to see how many glyphs we have, which I know that there's some like HTTP request JavaScript request. This isn't what I want. There's like some like function I can call that I just say like the URL fetch. This is probably what I'm thinking of. JavaScript fetch. This sounds familiar. Where do they use the XML, HTTP? No, that's the old way. Fetch. Here we go. Oh yeah, I just chuck it in there. Yeah, that's what I'm looking for. So here I want to say like fetch from whatever URL I said that the glyphs were at, which I think was glyphs. And you await that, I think. You say like glyphs response is this, and log the glyphs response. Boom, 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 boom. Nice. Okay, which, if I remember correctly, you can like extract the body as JSON prototype. JSON. Yeah. So then I want this to be a let so I can rebind it. And here we say await glyphs response JSON. Maybe. Refresh. He doesn't like that. Redeclaration of let. Because this guy shouldn't have an extra redeclaration there. Hey, what's up? What's up? Glyphs response is not defined now. What the fuck? Did I misspell it? I sure did. There we go. Better. Refresh. Okay, sweet. So now we have like our object. This is how many glyphs there are. And so now we can say like, I have some number of glyphs. I forget, is it like this in JavaScript? Is this how I look into it? Or is it, do I have it as like a field like this? I think it's this one. I guess we can just look. It looks like it's like a dot. It's been a while. My JavaScript is not fresh. Yeah, okay, there we go. So that's the number of glyphs. And then I can say, for glyph num in this, except I need like a range of some sort. If I know JavaScript correctly, both work. Yeah, that doesn't surprise me either. This is not right. What's the like, oh, it's like C syntax if I remember correctly. JavaScript for loop. C syntax? For, yeah, C syntax. Yeah. For let glyph num is equal 0. Glyph num is less than this. Plus glyph num. Maybe? We'll just log the glyph num here just to make sure. Glyph num. So here I refresh, glyph num is not defined, of course. But I typed let here. Is that not right? Am I high? Glyph num is not defined at line 5. Do I not put a let like that? Glyph num is not defined. What the fuck? Why? For let I is equal to 0, did I use semicolons? Can I just copy paste this and console log I? Just before doing any of this. Refresh. Okay, so that works. What's the difference between that and what I did? Oh, did I do plus glyph num and it's glyph num plus plus? Glyph num is misspelled in comparison. Yeah. Every goddamn time. Thank you. All right. Glyph num is undefined still. Because again, it's misspelled there. Good catch. There we go. Okay, so we iterate all of them. And then for each of them, we're going to fetch glyphs and string concatenated with the number. Okay. And then what's like there's a way to like chain stuff. JavaScript promise chaining. I think that you just like, is it like dot then? Set timeout, no. Then, yeah, that's what I'm looking for. So you do something, then you do something else. So once we get the glyph, we're going to take the glyph. Is it passed as like, yeah. So this is the response, and we're going to try to, is this going to be the new misspelled width? Yeah, dude, almost certainly, right? Glyph is such an unnatural sequence of characters. I wouldn't be shocked if I misspell it like 1,000,000 times. Okay, so we fetch it, then we get the response, and we get the body of the response, I think? response body. Let's just no, we don't want the body. We don't want to do that. We want because the thing that comes back is a PNG. So for each glyph, we can just inject it into the DOM. Yeah, as an image. So I actually don't want to do a fetch here at all. I want to say document body append child image, and then we're gonna have to make an image. We're gonna say image is equal to document create I'm pretty sure it's create element image. We set image source is equal to like glyphs, spelling it carefully, plus glyph num, spelled carefully again. And I think that's right. If we serve that. We see a bunch of images with no source. JavaScript set image source. Image.src, not image.source. Yeah, that does sound like it, eh? Refresh. Hey, there we go. There's all our glyphs. Very, very sick. Okay, so what's that? 40 minutes? 30 minutes to get anything shown on the web? Which is shit. But maybe the rest will move smoother, and maybe it will be faster for the next time I do it. Okay, and this is kind of nice because they're all like super in line with each other, so we can actually like tell that these look okay, right? A, B, C, D, F, G, H, I, J, K, L, M, N, P. Yeah. Okay, that's pretty sick. Okay, so we have all of the images, and then we also want to be able to see the sort, like our sample image that we're rendering, as well as the like textified version of it. But we were starting to get like somewhere, which is nice. So we'll go back here, and instead of returning here, we're gonna do all the stuff we would normally do. But instead of printing anything, we store this in an output image, and just instead of saving this here, I guess we'll set it as an attribute that we pass into the server. So instead of this output image like this, we'll say output image like this, goes into the server. This is the output image, and self.output image is equal to output image. I actually don't remember what that was supposed to be, so we'll find out in a second. We'll make a new path output. Output. And this is going to be an image, and this is almost certainly going to be like the same thing, except instead of looking for the glyph cache, we're just going to say output image. Okay, so what's that look like? Visualize. I think it was just this output. Oops. So, shit. Oh, it's okay. This is just printing for standard output. We can ignore that for now. That's nothing to do with like image generation, so I think we can just ignore that. Okay. So we have something that's just a black image. That's not good. But we have like an image at all, which is maybe something. I think probably this sampling stuff is probably broken compared to what it was before, so that makes sense. We're going to have to adjust that later. Maybe now, actually. So the problem is now that before we were only generating glyphs for the few characters that we cared about, right? We only had like a few of these, and we were just indexing into our like glyph cache manually. Now we actually have to sort these like a little bit more intelligently. So maybe what we can do for now is just use these ones down here, right? These look before we were using like characters A, B, C, D, but for now, let's just, these guys are like sequential in the cache and sequentially increasing in like pixels taken up. So these, oh dude, these are gonna be so sick, by the way. These guys over here, these like fucking dithered, that's gonna be so good for like 50% brightness. But anyways, I'm getting distracted. Definitely distracted. Okay, so can we like inspect these? And this is 1295 was the first one, and these are all sequential. 1295 to 1302. 6789012. Yeah, okay. So let's go back to our car lookup. And for now, we're just going to replace these with 1259. Wait, was it 1295? 1296, 1297, 1298, 1299, 1300, 1301, 1302. So these are now the like 0 to max brightness indexes. And so now when we get the label, wait, what the fuck? What the, does this have to be multiplied by 255? Sorry, I'm just getting like a little distracted. Why was our image black there? He shouldn't have been black. Here. Oh, there we go. Okay, okay. So he was just off by, it was like the normalization of the image. Okay. So here we have our like input image, which is actually called output here. Why? Why? Oh, because when we were doing this last time, we like sampled the image and then stitched together the samples again. So I don't actually care about that at all. We want this to be not the output. We want this to be like the labeled thing. So when we generate our labels, what do? We extract samples and then we label them somewhere. Yeah, get labels for samples, which we just get the index from the entire glyph cache, which is wrong. This won't work anymore. So here we're just gonna, for now, instead of, so we took like the brightness and we matched it to some character, like the character index in the glyph cache. We turned it into an index. And so now we can just say that this is, we don't use this anymore. We say the number of characters is 1306 or 132 minus 1295. And then we add 1295 back at the end. Maybe? I actually don't know. I haven't really thought about this at all. Okay, so now we can like look at the labels. And we should just see labels that are like in the range of 1295 to 3. Yeah, okay, cool. So these look about right. And then we can say that we, instead of copying the input image here, we should copy in, this should be bigger. Times y times num x samples height, sample height, and sample width. Sorry, I'm just saying words out loud without explaining what I'm talking about. Okay, so before we were working in like the image space, we have like two images. We have like a small one and a big one. The small one is what we like put in, and the big one is because the characters are rendered bigger than the sample that we take from the small image. So we have like this like image for comparison, which is the upsampled version of it. And we just need to say that like when our outputs are going to be not the sample height and sample width here, but like the sample height for sample for comparison height and sample height comparison, we'll call it. And just anywhere that we use sample width and sample height in here, that's fine. And then we say, where does like sample height come from? So we have number of samples. Here we go. So then we can say that the sample height comparison is the sampler image for comparison width or height over num y samples. There we go. Yeah. And so this is width and num x samples. We forgot a underscore, and this should be shape 1. Okay, so hopefully now if I then put as my output, I copy this from, instead of data, I just copy this from the glyph cache. Glyph cache at the index of label. I think that should work. We'll see if it crashes though. So it doesn't like this because there are not, these are floating point numbers probably, so I just have to integer everything here. Which is annoying, but it is what it is. Just integer everything. Okay, so that looks... There we go! Okay. Sick. So... That actually kind of looks cool, by the way. But also not right, like, not right by a long shot, but cool for sure. Sweet. Okay. We're getting close to having like a visualization of any kind, which is exactly what we want. Okay, so the other thing that we need to give is not just the output image, but also the input image. Which, oops, we want to change this one. So we do the same thing, but instead of, also the output image doesn't need the glyph number. Okay. So this comes from now input image, and everything else here is just the same. And don't worry, I'm very aware of the like insane amounts of duplication here. I'm just trying to like, I'm trying to get to like something that looks reasonable. Not reasonable, but at least like I want to like get the idea on paper so that I can decide how much I want to refine, right? It doesn't make sense to refine until I decide that it makes any form of sense. So I just want to like look at it and figure it out from there. So here we have the output image times 255, and inside we probably have the server or sampler image that we saved times 255.0. And which means that in our server we need to take in the input image like this and save it. Which means that here when we restart, I think that we should have a way to look at input. Yeah, nice. Input, output, solid. So now all we have to do is put those in our index here. We can say that we're going to have an image with source is equal to input. Is it with the closing tag like this, I think? And output. We serve, and we refresh. Okay. So these guys need to have like fixed widths. And actually, I can probably, instead of restarting the server every time, I can probably run this in a separate shell, because I think that the way I implemented it will have like the HTML refresh every time. So I can just say visualize here and foreground here, and I guess we'll put this in like a div with a comparison image, full image comparison as its ID, because then I can just make CSS rules for both of these. I think that'll make it line up. Like I think I can then go in here and I can say like full image comp image width, is it equals or colon 50 pics? Like what happens if I do this? Okay, yeah. Sick. So like, can we say like 50%? Maybe a little lower, 40%? Okay, there we go. They are different heights, but that's okay. And then can you do like align self-center, if I remember correctly? No, that's only for like Flexbox or something. Align items in div. Do I just need to do it with Flexboxes? Maybe. Which means that here I could do like full image. Oh god. Full image comp. Elite JavaScript trailer? No. I don't know what the fuck is going on. I'm so lost. Display flex. Oh, okay, wait, that looks okay. And then but then they stretched, so then it's align self here. There we go. Yeah. That's what I want. That's what I want. It's coming together. It's coming together. So here, it's like style, HTML, CSS, style sheet. I can never remember. I always want to type style, and that's not it. It's like, where does it come from? How to add CSS. Link. This is it. Okay. So this comes from index CSS. I think that's what I called it. Yeah. It's coming together. So now I refresh. And it looks like the style sheet. Oh, it's here. So why is this not working now? These guys don't have their style applied. Link, style sheet, ref, index CSS. Style editor has index CSS with 0 rules. Is it because... But I see the rules here. Am I high? These worked a second ago. Oh, I see. The style sheet was not loaded because the MIME text index text HTML is not text CSS. Okay, so we can maybe it's time to start cleaning up some of this fucking shit show here. So def send response, and we're gonna take in the header, I guess, and like the content. Or call it like maybe, I guess some of these guys are writing out with like a function that takes us in. And we have to write to, do we have to write to the, well, okay, hold on. If we write to the W file before we set the headers, does that fuck everything up? Can we just do this on like the index version? Like if I do this, does that get fucked? Oh, I need to restart the server for that to count. Every now and then I try to do some web development, I jam at the backend, I start writing front end, boom, I give up on the project. Yeah, I've done that a lot of times for sure. Fuck, it does have to be in order. Okay. So I guess that this is going to take in like def send response or respond. I don't know, send response already exists, so we have to make a new function like respond. And this is going to take in self as well as the header or the content type, I guess. And a like writer function. And does that make sense? So then we have like this stuff gets set for free. I guess we'll just say set response headers. There we go. Then we don't have to do this. So this gets set to the content type. And then here we can say self set response headers with application JSON. Then all of this bullshit gets deduplicated, I guess. The image stuff will have to be duplicated, but that's okay. Oh shit. I set everything to application JSON. That's gonna be a problem. So this is text HTML. This is image PNG. This is image PNG. This is image PNG. Nope. This is application JSON. No, image PNG. Okay. Okay. So now, what was I trying to do? I was trying to deduce the content type, the response, the MIME type from the content. So we can say self.path as a pathlib path. And then there's like pathlib path extension. I know that it's not what I think it is. Extension. Suffix. And we need to import from pathlib, import path. Okay, so this will tell us what the suffix of this guy is, and we can try to deduce the MIME type based off of the extension. So here, I go back to my thing here, and I refresh, and he's going to say, fuck, there's too many gets logged. Can I go back? Back. I want to see the print of the suffix. Scroll. So it has the dot in there. So I can just say, nope. Fuck. Here, I want to say, path to MIME type. Self.path. And then we define path to MIME type. And we take in the path. We convert this into a pathlib path. We take the suffix. And I guess we'll say suffixes is a dictionary of strings to strings. And we just say .js is text JavaScript, I think. HTML is text HTML, and CSS is text CSS, and then we just return suffixes this guy. Okay, does that run? Oopsies, we'd run that here. Certainly, I've made a mistake in there. Oh, nice. Okay. So here our style sheet looks like it's actually been loaded. Nice. Noise. And can I like increase the margin between these guys? They're a little too close for my liking. Margin 5 pixels? Does that like... There we go. Okay. Not bad. Not bad at all. All right. Okay, so now the fun part is I wanted to be able to select an individual area here and show which of these characters had like the best scores. So I guess we're going to have to add like a mouse click handler to the source image. And then maybe we want to show it on both the left and the right. Maybe. And then we'll have to like sort these guys. And I'm just trying to think like, then we're also going to have to like pipe scores. So right now our labeling system just says like which label is best. But we're going to have to say more now like what are the scores of each of the labels. I hear the front-end developers screaming from over here, you need React, you need dummy, use Tailwind CSS. Yeah, I'm sure. I've never used React, and I doubt I ever will. My gut says that like simple JavaScript is good enough for anything I'm going to do, but it's also possible that everything I'm doing is taking like 10 times longer than it should. So, who knows? Not me, but we'll see. Just don't save yourself from Satan. Okay, so I think that what I have here is we've updated our glyphs to like we've like now got all of our glyphs. We have something to look at. We have like this like simple little visualization, and I'm looking at the clock and thinking about like how much work is left to get what I wanted to do today done. And I think it's like still actually a significant amount, right? I want to like click on here. I want to like draw a little box. I want to like blow it up. I want to like see the individual sample and the scores for each of these guys, which means there's like back-end piping to do. So I think that that's like enough stuff that it's worth doing another stream to get there. I was kind of hoping that we would get to like the interesting part of like label generation or like improving our label generation. But I do think that the visualization stuff is like a worthwhile investment. Every time I've ever like done this, I'm like immediately like it pays off like so fucking fast. It pays off so quick because like the workflow of like run code, look in a folder, look at images, try to correlate with text and all that. It's so long. And so I think what I'm going to do here is I'm going to call it, come back tomorrow, finish up the visualization, and hopefully tomorrow we get through that fast enough that we can start working on the loss. But if we don't, then that's fine too, right? It's fine to like at least just get the visualization side down. So fun stuff. Thanks for watching. If you liked what you saw, I stream most days at around 1 or 2 o'clock Pacific time, somewhere in that range for around like 1 or 2 hours. If you miss a stream, then there's a YouTube link in the Twitch description where all the VODs go up. If you're watching on YouTube and you want to come say hi, chat, whatever, tell me I'm shit, any of the above, there's a Twitch link in the YouTube description. And what else? Code for this, not in this state for sure, because what we wrote today was like shit, right? I just want to make that clear. We banged out a lot of quick code that looks like garbage, so it's not going to go up in its current state, but it will go up in some state eventually to this like GitHub page. So I'll paste this in the YouTube description as well. And what else? What else? There's a Discord link in the Twitch description. Yeah, that's it. So thanks for watching, guys. I'll catch you on the next one. Bye.